In the previous chapter we studied syntax, what a well-formed formula looks like. But syntax alone is not enough. We also need meaning. Semantics tells us whether a formula is true or false under a given interpretation. In propositional logic, the standard approach is Tarski semantics. Give each variable a truth value, either 0 or 1, and then evaluate the whole formula by applying the rules for the connectives. Evaluation is simply a function that maps propositional variables to 0 or 1. Once we have evaluation, we can compute the truth value of any formula. A truth table goes further. It tries every possible assignment of zeros inference. For example, 0 and 0 gives 0, 0 or 1 gives 1, and 0 implies 1 gives 1. Also remember that our connective is inclusive OR. If both sides are true, the disjunction is true. With truth values in hand, we can define the central concepts. A formula is satisfiable if at least one valuation makes it true. It is a tautology if every valuation makes it true. It is a contradiction if every valuation makes it false. Two formulas are logically equivalent if they have the same truth table. Two formulas are equisatisfiable if either both have a satisfying assignment or neither has one, even if their truth tables are not identical. Satie asks a simple-sounding question: given a logical formula, is there an assignment that makes it true? This problem is NP-complete, which means we do not know a fast algorithm that solves every possible instance. But modern SAT solvers are remarkably strong. Many real problems, such as Sudoku or hardware verification, can be encoded as Satie and solved quickly in practice. The power comes from translating a search problem into logic. Here are two examples. For Hamiltonian path, we can use a variable x sub I, j to mean that vertex I is visited in position j, then add constraints saying each vertex appears exactly once and adjacent positions must be connected by edges. For Sudoku, use x sub I, j, k to mean that cell ej contains digit k, then add constraints for rows, columns, boxes, and uniqueness. The common pattern is encode the solution conditions as a formula, then ask whether the formula is satisfiable.